Okay, so we'll now look at part 2 on the inverse trig functions. And these are the ones where we're doing composite functions. We're doing a composition of 2 trig functions. So you're going to have a regular trig function and also an inverse function, and they'll be composed together. All right, so there are several different scenarios here as we start working these problems. So let's start with the first one, tangent inverse of tangent of negative 2 pi over 3. And let's see what we can do with that. All right, so what I'm going to do first on this one is I'm going to deal with what's inside the parenthesis first. All right, so I'm going to come off to the side somewhere, and I need to figure out what tangent at negative 2 pi over 3 is equal to. So let's go ahead and draw that angle and think about a reference angle. All right, so negative 2 pi over 3, if I take it back to unreduced form, that's 4 over 6. So I'm going to count it out. This is, remember, we're rotating down. So this is 1 pi over 6. This is 2 pi over 6, 3 pi over 6, 4 pi over 6. Okay, so let's get our angle there. So there's my initial side. There's my terminal side. And remember, our rotation is negative. Okay, so now I need a reference angle. So my reference angle is going to sit here. And so that reference angle is going to be 60 degrees, or pi over 3. And this is where it's important to draw it neatly, because I can see it now by looking at my graph that I have a 60-degree spot in there for the reference angle. So tangent of pi over 3, that is a memorized value for me. Tangent at pi over 3 is going to be square root of 3. Okay, and then I have to adjust for the sine. So remember that on the tangent, plus, plus, minus, minus. So the answer is supposed to be positive. All right, so I'm going to go ahead and say that that is equal to positive square root of 3, just like tangent pi over 3 is equal to square root of 3. Okay, so now I'm going to come back up to my problem, and I'm going to substitute that in. So I'm going to leave the inverse tangent on the outside, but inside the parenthesis, I'm going to substitute in my square root of 3. All right, and now I think to myself, this is asking me for an angle where tangent is equal to square root of 3. My restriction on the inverse tangent is quadrant 1 or quadrant 4. Remember, quadrant 1 is for the positives, quadrant 4 is for the negatives. So I need a quadrant 1 answer because square root of 3 is positive. So where in quadrant 1 is tangent equal to square root of 3? And I know that that's at pi over 3. All right, so that takes care of the first one. All right, so the second one, we're going to kind of do the same thing. We're going to go inside the parenthesis first and work on that. So I need to deal with sine negative 3 pi over 7. All right, so let's draw it first. Now, this is not an angle that I am familiar with, so I've got to kind of figure out which quadrant this angle lies in. So I know that I'm rotating in a negative direction, so I'm coming down. I know that if I were to go all the way over here, I would be at negative 7 pi over 7. Okay, and I'm using the 7s because that's the denominator in this. All right, so negative 7 pi over 7. All right, half of that would be this line right here. So half of 7, what is half of 7? Half of 7 is 3.5, 3.5. So, I mean, this is not really pretty, but 3.5 pi over 7 would be right here. Okay, and then if I compare my answer in parentheses to that, I want to plot negative 3 pi over 7, so that's not quite as far as negative 3.5 pi over 7. Okay, so when I draw my graph, my angle, there's my initial side. My terminal side is going to come in maybe right about here. Okay, but quadrant 4. So you want to make yourself a note, hey, that angle is in quadrant 4. All right, so what is sine at that angle? I have no idea. Okay, so I'm just going to come back up here and I'm going to say sine inverse. I do know that at that angle, the sine is going to be something negative. Okay, so I'm just going to put something negative here. I don't really know what it is. Negative something. All right, so now I'm doing an inverse sine of something that's negative. So I know that on my inverse sine, I'm limited to quadrants 1 or 4. That's my restriction. 1 is positive, 4 is negative. So hey, I'm saying, okay, I need to be in quadrant 4, but guess what? I'm already in quadrant 4 with this angle, so my angle is not going to change. All right, and so my answer will just be negative 3 pi over 7. And remember that we talked about this in class, and we talked about where sometimes the inverse and the function itself, if they're the same function, like sine inverse and sine, sometimes they just undo each other and they cancel each other out, so to speak, and you're left with your angle. And that happens as long as you're staying in the same quadrant. If you don't need to move to a different quadrant, then you're good to go. All right, so let's look at the next one. So we're going to start inside. I need to figure out, first of all, what sine 5 pi over 4 is equal to. All right, so I'm going to draw it first, 5 pi over 4. This is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, here's 5 pi over 4 right there. All right, so I'm going to draw my angle real fast. There's my initial side. There's my terminal side. It's coming around in that direction. All right, so that angle is in quadrant 3. Remember that your reference angle in that case would be pi over 4. I know that sine pi over 4 is square root of 2 over 2. And I know that in that third quadrant, it should be negative. All right, so the answer to this would be negative square root of 2 over 2. And I can come back up here to my problem and plug it in. So now I'm going to do a cosine inverse of negative square root of 2 over 2. So remember that this is now asking me for an angle where cosine is equal to negative square root of 2 over 2. Remember that that cosine inverse limits us to quadrants 1 or 2. 1 for the positive, 2 for the negative. So I know that I'm going to need to be in quadrant 2 with my answer. So what do I know from a memorized value? I know that cosine of pi over 4 is equal to square root of 2 over 2. That's my first quadrant angle. All right, let's take that pi over 4, which is sitting here, and let's reflect it into the second quadrant because that's where we need to be. All right, what is that angle? That is 3 pi over 4. And so that will be my answer, 3 pi over 4. Okay. So moving on to the next one. Again, start inside. So we're first going to look at cosine inverse of 1/2. All right, so that is going to mean that I need an angle where cosine is equal to 1/2. Since it's positive, I know that I'm in quadrant 1, which makes things easier for me. What do I know? I know that cosine is equal to 1/2 at pi over 3. All right, so I know that the answer to this expression is going to be pi over 3. So let's plug that in. So I'm going to be doing sine of pi over 3. And so that to me is a memorized value. I know that sine 60 or sine pi over 3 is square root of 3 over 2. So that one ends up being fairly easy because we are sitting in that first quadrant. All right, the next one, tangent inverse of -1 is where we're going to start. So I'm going to come off to the side somewhere. I need to find an angle where tangent is equal to -1. So what do I know? I know that tangent at pi over 4 is equal to +1. All right, I also know that if I'm doing an inverse tangent, I am limited to quadrant 1 or quadrant 4. 1's for the positive, 4 is for the negative. So I need to be in quadrant 4. So let's get it there. So we know that it's based on pi over 4, which sits here. But now I need to reflect it down into quadrant 4. So the angle that we're looking at is going to be there. We're going to rotate down, and so our angle will just be negative pi over 4. So I have cosecant negative pi over 4 for the part inside the parentheses. Okay, so let me think about this for a second. So that negative is on an odd function, so I'm going to go ahead and bring it to the front just to kind of get it out of the way, because cosecant is an odd function. I know that cosecant pi over 4 is the square root of 2, and then I have that negative sitting in the front. Okay, so final answer there should be negative square root of 2. All right, so these last two are problems where you are going to have to draw a triangle to figure out your answer. And I know that that's the case because when I look at the inside portion of this, and I think about asking myself, okay, where does sine equal 1/3? I have no idea. Okay, that is not a memorized value for me. So it is not something that I'm going to be able to come up with and give an answer to that. So we're going to draw a picture of it instead. So it is a positive 1/3, which means that I would be in quadrant 1 on this inverse. So let's go ahead and draw that angle in quadrant 1. I don't know exactly where that angle is, and it doesn't really matter. Let's just sketch an angle in quadrant 1. And we're going to call that angle theta. Now we're going to make a triangle out of that angle. So I'm going to drop a line straight down. I'm going to remember that on the sine SOHCAHTOA, that's the opposite. This is the hypotenuse. So hypotenuse is 3, opposite is 1. I'm going to do Pythagorean theorem to find that missing side. So a squared plus 1 squared equals 3 squared. A squared plus 1 equals 9. A squared is equal to 8. Taking the square root of both sides, we get A is equal to the square root of 8, which is going to simplify to 2 on the square root of 2. Okay, so now coming back to my problem, where is sine equal to 1/3? I don't know, but I do know that I've got this picture drawn of it, of that angle theta. So now all we need to do is find tangent of that angle. So tangent is opposite over adjacent, so we're going to have 1 over 2 on the square root of 2, which we're going to rationalize by multiplying top and bottom by square root of 2. So that's going to give me square root of 2 on the top. It's going to give me 2 times 2, which would be 4 for the bottom. All right, so final answer there, square root of 2 over 4. All right, and then the last one is going to work very similarly. I'm going to look at the inside portion of that problem. I'm going to ask myself, where is cosine equal to negative square root of 3 over 3? Now, that's a little tricky because that is a memorized value if we were talking about a tangent or a cotangent, but it is not a memorized value for a cosine. All right, so I know that on an inverse cosine, I'm limited to quadrants 1 or 2. Since this thing is negative, we're going to need to draw an angle in quadrant 2. All right, so let's go ahead and do that. Let's get our angle drawn in quadrant 2. There's my initial side. Somewhere in quadrant 2, we'll draw a terminal side. We're going to drop a line straight down to the x-axis and form a triangle. And we're going to be using this reference angle that sits right here. Okay? And so for cosine, SOHCAHTOA, this is going to be adjacent over hypotenuse. So adjacent is going to be the square root of 3. It will be negative because we're moving back to the left. And the hypotenuse is going to be 3. All right, so now we're going to do Pythagorean theorem again. So a squared plus negative square root of 3 squared equals 3 squared. So a squared plus 3 equals 9. A squared equals 6. A equals the square root of 6. All right, so we'll put the square root of 6 on that side. It's going to be positive because it's moving up. All right, so again, when we look at this middle part, I don't really know an answer to that, but I did just draw a picture of it and called it theta. So we're going to be finding the cotangent now of that angle in the picture. So cotangent is adjacent, which would be negative square root of 3, over opposite, which would be square root of 6. Okay, we're going to rationalize by multiplying top and bottom by square root of 6. So we're going to have negative square root of 18 over 6. Okay, and we have a little bit more work to do here on this one. I'm going to run out of room there. Let's see if we can stick it up here. All right, so that negative square root of 18 could be written as 9 times 2. I can take the square root of the 9, making it 3, but I can't take the square root of the 2. All right, so we're left with negative square root of negative 3 on the square root of 2 over 6. 3 goes into 3 once, 3 goes into 6 twice. All right, so we actually have as our final answer on this one, we have negative square root of 2 over 2. All right, and so that finishes up those problems. So there's a lot of moving pieces with these, and you need to practice to be sure that you're okay. Remember that you're always starting on the inside of the parenthesis and working that part first. You have to remember your memorized values. You have to remember the restrictions on the domains for the inverse functions. Okay, and again, if you've gotten one wrong and you need to ask questions, you don't understand why you missed it, send me an email so that I can help you with that problem before the test.